Okay, so this is the basic setup of the simple harmonic motion virtual experiment. Right now you just see a rod stand sitting on the table, okay? And let me come in a little closer. You'll see a spring hanging up here. Okay, so that's the spring, and just in its normal unstretched position, okay? Down on the table, I've got a mass hanger and then 3 of these discs here. So the mass hanger weighs 50 grams, the disc weigh 20 grams each. I'm going to put them on. Okay. All right. Okay. Now we're going to take this and hang it on the spring. All right. Okay. So then you'll see it just hanging on the spring like that, right? Now, at this time, the spring is not in its normal position. It's being stretched out, but it's essentially motionless. You'll see it move around a little bit, but we'd have to wait a long time for it to be completely motionless. But anyway, this will be what we call the equilibrium position, where it's essentially motionless. So the amount of force that the spring applies to the mass is at this time pretty much balancing its own weight. Okay, now what we'll do a lot in this experiment is I'm going to pull it down and set it in motion. Okay, so stretch it a little bit and then it's in motion. It may look a little crooked, it may wobble a little side to side, but just for the purpose of showing you. So this is basically simple harmonic motion right here. Okay, this is what we'll deal with a lot in this experiment. Okay, so now what you see is slightly different from a second ago. Notice that down there low, there on the table, I've got the motion detector now. So it's pretty much in a line beneath where the hanging mass is. This video is coming out a little dark, sorry about that, but hopefully I think you can still see it. So what I'm going to do is pull the mass down like before and start it oscillating. And what you'll see on the computer screen is a readout from the motion detector showing you the position of the hanging mass as a function of time while it's oscillating. Okay. Okay, so anyway, we're not going to use the detector in the experiment, in the rest of the experiment, but I just wanted to show you that really quickly because you know, you see sine waves so much in this when you're studying this material, and it starts to seem kind of abstract after a while, but hopefully this will remind you that sine waves really do correspond to real things. So this sine wave is a function of the hanging mass's position as a function of time. So as it moves up and down, it really does trace out a sine wave pattern. Okay.